Hi, I'm Carl, and in this video we're going to go over questions 22 to 26, section 3 of the blue booklet. So this covers Unit 6 and Unit 7. Question 22 is a quick question about a lens where three beads are placed between or in front of a lens, and on the other side of the lens there are two screens, and this asks what the position of the images would be formed. So we have a converging lens here, and we're told that the blue and the yellow beads are below the principal axis, and the red and the green would be above the principal axis. And with a converging lens, things cross the principal axis. So those are below will end up above, and vice versa. So we know that the positions 4 and 3 will have the blue and the yellow beads because they're below the principal axis, and then when the light goes through the lens, it'll end up above the principal axis. Equally, with a converging lens, the other axis will be flipped too. So the beads that are closest to us will end up being further away from us. The images will end up being furthest away from us. So the red and the blue, which are the ones that are closest to us now, will end up as images furthest away from us on the screens on the other side. So that means they swap positions in both axes. So this yellow dot will end up in the top here. So in position 3 or 4, it starts off furthest away from us, it'll come closer to us, and it'll end up therefore in position 3. The blue there then will starts off at the bottom below the principal axis, it'll end up above it, so it'll be in position 4 or 3, starts off nearest to us and ends up furthest away, therefore it'll be in position 4. The red and the green will end up on the lower screen in positions 1 and 2. The red is closest to us, so the image will end up furthest away, so the red will end up in position 1, and that leaves green to be in position 2, which makes sense. So we're looking for the answer that's 2, 3, 4, 1, and that in this case will give us an answer D for 22. So moving on to the next unit, which is Unit 7, and this asks about some flatfish, their eyes and their positions and the genes that are responsible for this. And there's 3 different hypotheses that are proposed here. It's worth having a read over all this before we go through it. Question 23 says, from hypothesis 1, it can be concluded that the offspring of a cross between a Japanese starry flounder and a right-eyed west coast starry flounder would what? So in hypothesis 1, it talks about how there's going to be this dominant allele here, and Japanese fish are going to be homozygous for this, and west coast fish are going to be homozygous for the neutral allele, which is going to be lowercase in both cases. And in this case, because they have a neutral allele, there's an equal chance of developing into either left or right-eyed individuals. So that's hypothesis 1 and how it applies to this question. So if we did a Punnett square for this, we can see that the offspring would have these genotypes. All of these have the dominant capital L allele, and therefore would all be left-eyed. And so the answer for this one is going to be C. If we look at 24, then it says, according to hypothesis 3, which is a little bit more complicated, it says many crosses between the given individuals would result in what proportions for phenotypes. So we're given 2 genotypes that the parents would have, and we'll just draw these in now. So we've got this combination here. So if we drew a Punnett square for this, and then work out what all the different genotypes of the offspring could be. Okay, so let's have a look at what the phenotypes would be, because they both have the capital L's. These top 2 will both be left, and then the bottom ones, this will be this one will be right. And then here we've got a 50-50 chance of either. They've got 2 copies of the neutral gene, and so there's a 50% chance of them becoming right or left-eyed. So 50% of the chance they'll be left or right-eyed. So what does that mean for this then? Because out of 4, that means on average we'll have 2.5 fish with left eyes and 1.5 with right eyes. Obviously that gives us then a ratio of 5 to 3, which is a bit nicer. And so we know that 5 out of 8 will be left-eyed. So 1/8 is 0.125, so 5/8 is going to be 0.625. So roughly 60% of them will be left-eyed, and therefore 40% of them would be right-eyed. And that gives us proportions that are closest to C. So the answer to this one is going to be C as well. So if we look at 25, it talks about hypothesis 2, which is the one with equal frequencies in left and right-eyed alleles in the West Coast population. So it says, from hypothesis 2, it can be concluded that the offspring of many crosses between Japanese starry flounder and randomly selected West Coast flounder would be what? So again, it's just a matter of doing our Punnett square. We end up with a cross that looks like this with hypothesis 2. So if we work out the genotypes, let's think about what the phenotypes might be. So we get this cross here, which means we definitely get two that have an extra left eye, and that's in this row here. And these two both have a 50% chance of becoming right-eyed and 50% chance of becoming left-eyed. And so what that means is that we'll end up with a ratio of 3 to 1 left to right. And that means that there's going to be 3 left-eyed flounder for every 1 right-eyed flounder, which gives us an answer A for 25. Okay, so let's have a look at our final question, which is going to be 26. It says, when a left-eyed female and a right-eyed West Coast male were crossed, the offspring were all kept in standard conditions on the West Coast of the USA. 50% of the thousands of offspring were right-eyed and 50% were left-eyed. So does this rule out any of the hypotheses? Well, because there's 50% of them that are right-eyed and 50% that are left-eyed, that makes it a little bit complicated. Looking at hypothesis 1, it says that the dominant left allele, Japanese fish are homozygous for the dominant left-eyed allele, but it doesn't say anything about the genotypes of the Pacific or the mid-Pacific fish. So we couldn't really say too much about hypothesis 1, so there's no way to really rule that one out. For hypothesis 2, again, it talks about the either West Coast or Japanese fish. And there are combinations of alleles that could give a 50% chance of each. So number 2 couldn't be ruled out. And the same is true for number 3, because they have this neutral allele, and because there's an equal chance of developing into either side, and there's options for them to be either right-eyed or left-eyed in the homozygous state. There's no way to rule out number 3 either. So that means that we can't really rule any of them out, and so the answer to 26 has to be D. So that was questions 22 to 26, or Unit 6 and Unit 7 of the 3rd section of the Blue Booklet. I hope that helped. Thanks for watching.